All right, it's about that time. Welcome to the last meeting slot of the week, where we will be talking about Privacy Pass. Let's see. So we still need a note taker. It's not all that difficult, just writing down kind of the main topics and then any kind of important points and discussion of any resolution of issues. Anybody willing? Will help us get started if we can find a note taker.
I'll do it.
Great, thank you. All right, so next slide. If you can, Ben, or I guess I can control it. There we go. Note well. So it's Friday. You haven't seen this already and figured it out. Well, you should. It's so please recognize you're under the rules of the note well. Next slide. All right, so for our agenda, we'll have a short update of the status of some of the working group documents, then rate limit tokens, batch tokens, discussion of key consistency, and then public metadata tokens. So any agenda bashing? I want to add something or take it off. All right. So just to jump in on working group documents, I think we have we've closed the last call on main core documents. I think we may need to just there may need to be just one other revision to. I think there's. I don't know if all the changes have been, all the merge changes have been reflected in the document, or if they need to be. So I'll follow up with the authors and see, but we should be good to go as long as we got all the things. And we just want to. I don't want to send something that we know has we'll have to change. And then we have a couple other documents in the works. One which we'll talk about now, which is rate limit tokens. You should have control.
Do I have access to?
I thought I just.
Because do I need to select which deck it is? Here we go.
I
got
think you should. It should be working now. Yeah.
Got it. All right. Hello, everyone. I'm Tommy Pauly from Apple, presenting on behalf of the co-authors. We do have Chris and Stephen in the room here. All right. So this is one of our adopted documents that is kind of not already through last call. It's one that we I think adopted last time we met. And so this is a variant of the publicly verifiable blind RSA tokens that allows for rate limiting. And again, just as background, if people weren't caught up on the previous discussions, this is a case where the rate limiting is being enforced on the device, on the machine server that's doing the attestation of clients. It doesn't know what they're going to, but it has anonymous buckets on which it can enforce rate limits. So there are several recent changes that we put out, I think in like the week before the draft submission deadline, that addressed many of the open comments. This is largely in line with what we presented last time at the meeting. The biggest and most substantial one is an entirely new section that goes into what we're calling penalization of issuers and clients that are detected as misbehaving. And so this is something that attesters do. And so on the issuance path, we have the client is attesting its device with the attester, and then if that passes and doesn't exceed the rate limit, then it gets a token issued by the issuer behind that, and the issuer is able to see the identity of the origin that the client is going to, but not the identity of the client. In order to avoid attacks where malicious issuers could leak out information by denying token issuance, we don't want the attesters to simply drop token issuance requests if it detects that the issuer is doing something suspicious. So instead, we have described in the text that the attester, when it detects collisions in these kind of anonymous buckets, to say that, oh, someone, either the client or the issuer, is fudging with things and trying to either leak information about clients, or this is clients trying to cheat, then essentially the attester will kind of keep a penalty count of a bad box for the various issuers and clients, and have thresholds that once you've detected enough of those patterns of collisions, then you kick out those issuers or clients, as it may be. And the heuristic that we suggest is essentially if you see a particular client getting multiple penalizations across different origins and issuers, then it seems like it's a client being sketchy. But if you see an issuer inducing these collisions across multiple clients, then it seems more likely that the issuer is the one misbehaving. And then you can essentially say, we're going to block trust with that issuer until we investigate the root cause of this. These are all things that would happen in exceptional cases when people are violating the protocol. So that's the main change. The second change was more, it doesn't actually change any of the compatibility or interop for the protocol, but there's a field which is named currently the anonymous origin ID. This is something that the client presents to the attester as a anonymous version of the origin name. It's just kind of like a random blob that the attester uses to bucketize the counts for rate limiting. And it can be calculated in different ways. It could be calculated just off of like a dictionary that the client has that it just comes up with random values. But we had some text that suggested if you wanted to derive it, there was a particular way to derive it. And we updated this to include the issuer name in the derivation, since we want to ensure that this anonymous origin ID would not be the same across different issuers if a particular origin moved its service from one issuer to another. And then the third change that was made is that we explain if we get a challenge on the client for a token, rate limit token that includes multiple different origin names, and this is mainly the case if you have some like third-party content on a website saying that it's rate limiting for itself, working on behalf of the main page, that the client should pick using that main page as the thing that it is doing the token issuance request on. So going through the open issues we have here, I think this one, yeah. Chris, had you written this? Had you updated this text? Yeah. No, exactly. Do you want to speak to it? I forget the context on this since you had been writing it. Oh, yes. Okay, I remember this discussion. So fundamentally, since the state about rate limits is being stored on the attesters, the corollary is that these rate limits are only enforceable per attester. And so if you are trying to do effective rate limited token issuance for a particular website, you want to make sure that even though you can definitely support a diversity of attesters, that it is not easy for a particular client to participate in multiple overlapping ones. And so you would want you would want them to be attesting things that are appropriate for what you are rate limiting based on. Martin, you're making funny faces. Do you want to? Let's talk about it. It's
sure. I mean, if you say the limit is 5, and then you have 500 different attesters, the limit is really 2,500, as far as I can tell. Right? That's just the way it is. Now,
right, depending on what it is. I mean, if it's like active, I don't know, email accounts with payment information associated with them, I don't know, like then
maybe you're comfortable with that, but
yeah,
I think the general shape of the problem is that you don't want to be able to have anyone else in the system be able to re-identify the clients such that they know that they're the same client.
Yes.
And unless you insist on having the attesters have some way of cross-correlating this information, which again is not a great thing to have, then you will have this property out of the system. And it might just be that you have a very limited set of attesters that are involved here, and a limited set of attestation methods as well, potentially. But I think this is just like a natural property of the system that you have, which unfortunately raises the question of centralization again, and all of those concerns. But I think we can probably bucket those in a later discussion.
Yes, yeah. So I think the main thing here is we need to expand the text and discussion of this and kind of give you the caveats of like, if you are giving a limit of 5 and it's email accounts, that means, all right, so you have a legit Gmail account, you have a legit this account, that account. And so if you're reading 5 articles a month, you get 5 articles per valid email account you have. And that's the nature of the beast.
Sorry, I'm trying to use the onsite tool. We do have some centralization considerations in the architecture document, but this naturally forces us to extend them for this particular document, which is an issue we should file alongside, clarifying the text here. And I will file the issue as I sit down.
We could also, and relate the issues, or I think that's very good. Yep. So this is a fun one. Yep. Okay.
It took a long time to get it.
Oh yes. Oh yeah. So this is just a bike shed thing. The names are unwieldy. The anonymous origin ID is not terrible, but the name for the thing that the issuer generates in response to it that you compare against them in the bucketing is pretty confusing and doesn't have a great name. So we should fix this. I don't have great ideas. If people do, please bike shed, but otherwise, I guess we'll just put our thinking caps on.
This sort of thinking is not really a good use of time in meetings.
Exactly.
Let's move on.
Yeah. So it is more just a cry for help. Please go, if you have ideas, go to GitHub. And then I think one of the other big important things to do is have more of a discussion and more of a reference to key consistency. So we also have our key consistency draft within this group. There is a slight difference here for key consistency from the basic token issuance schemes, because there are 2 keys going on here. There's the key that you use to encrypt the information to the issuer, and then there's the key that is actually per origin for your tokens themselves. And you want to verify kind of the consistency for the pair of those things. So that's something that we need to work on and discuss the different strategies that are appropriate and reference the consistency draft. on that. So yeah, that's essentially where we are. I think those are the big issues. We have done implementation work to update these. I think we have 3 or 4 different implementations of this right now. We are still tracking the CFRG dependency. The analysis of the underlying crypto there has been completed. Chris, you were in CFRG. I don't know if there's anything that we have an update on this.
We intend to ask for a crypto review panel next, and then it'll go through CFRG research group last call. So
Okay.
Those are the next formal steps. I don't know what the timeline will be. There's a lot in the queue right now, but
Got it.
it's moving along. This will
behind
not be the blocker.
that in the queue.
Yes.
Great. So I think that's it here.
Okay.
Got any questions? But I think mainly, if you have thoughts, please engage on the GitHub issues.
So it sounds like you really have only 1 or 2 issues that.
2 substantive issues,
and-
bike shed, and that, yeah.
And then we
Definitely.
still have looming the whole centralization
Yes.
discussion. which-
Exactly. That's
Okay.
right.
Okay.
Okay. Thank you.
Thank you. Next up, I think we have batch tokens. You want us to share the slides here?
Yeah, excellent. Hi, I'm Raphael. I forgot to put Chris's name on that first slide. Sorry for that. He's a co-author of that draft. So don't expect a huge breakthrough with this one. However, I think it's something practical. Next slide, please. So the proposal here is to have an issuance protocol for batched tokens. And the idea behind that is that we have privately verifiable tokens, but they're quite expensive actually. When you want to issue them in high numbers, that could be prohibitively expensive. And the reason for that is that the underlying primitive is P384, that is notoriously slow. It's a conservative choice. It makes sense to use that. But the alternative could be Ristretto, for example, and that's what's being proposed here. The other thing is that privately verifiable tokens use VOPRF as an underlying primitive, and VOPRF has these zero-knowledge proofs that actually support batches and are way more efficient when you do that. However, the issuance protocol has no way of using that, so you cannot really compress anything here. You can only request one token after the other. Next slide, please. So how can we improve that? The idea here is that we take a single token challenge, reduce the size of the proof by essentially issuing multiple tokens for that one challenge. And so that way we amortize the cost per token. So both for the proof generation and the verification, actually the payload is also constant size, so it's smaller as well. Next slide, please. So in practical terms, the upper struct is the token request from the privately verifiable tokens. The lower one is the one from the batch token. So you see the difference is pretty small. In the upper one, we have one blinded message. In the lower one, we essentially have an array of blinded elements. It's fundamentally the same thing. Next slide, please. So for the response, it's the same thing. We have an evaluated message for the privately verifiable tokens and an array for the batch tokens. Next. Thank you. Yeah, so on the security side, as I mentioned earlier, P384 is a conservative choice. If you use something with a smaller key size, there's a warning here. So that couldn't be enough in some scenarios. So this quote is from the VOPRF document, and the suggestion, or rather the mitigation strategies, the first two ones are also from the document. So I think it's fairly straightforward because those are things that you should do anyway. So limit the issuance of tokens seems like a good idea. You shouldn't have a system where you can request, an arbitrarily high number of tokens in a certain time window. The other thing is you can also mitigate this by rotating keys regularly. This is again something I think you should do anyway, because if you don't do that, you have the hoarding problem that you have with a lot of those variants, if not all of them. So it's something to remember, something to take care of, but I don't see that as something fundamentally prohibitive. The other option would be to define another token type with a larger group. So of course we would lose a bit of the efficiency, but it could still be badged, for example. So this is an open question. If folks feel like we should do that, then we should absolutely discuss it. Next slide, please. Right, so here's a performance chart with the publicly verifiable tokens, the privately verifiable ones, and the batch ones. And the batch ones here, so this is a batch of 100 tokens, and so the execution time is per token. And so you can tell that they're much faster than the privately verifiable tokens. However, please take this with a grain of salt, because this is using Rust crypto, and I have a feeling that the implementation of NIST curves in Rust crypto is not optimal in terms of performance, but I didn't check this, to be honest, against other libraries. But still, you can see that we are talking about more than an order of magnitude. So yeah, essentially that's the motivation behind it all. Next slide, please. So we have two implementations that currently implement that, and they interop. So we have an extensive set of testing vectors that will pass in both directions. So yeah, we have the running code. Now let's see if we can get rough consensus. I think that was the last slide, if I'm not mistaken. Yeah, please, Steven.
Stephen Valdez, Google. So I think I'm generally supportive of the batched half of this. Private state tokens, which uses an older version of PrivacyPass that did have the VOPRF batch code, is what we're currently using. So having this standardized would be really great. I think there are two parts here. There's the batch part, but there's also this move to Ristretto. I think at least in our use case, we find that because of some of the privacy properties of like rotating our keys too frequently, we don't want to be doing at least the mitigation that involves rotating frequently. So it would be good if we could get a version of the batch code that still uses the like P384 version. And maybe we can just have both in the spec or something.
Yeah, good point. I think it would be worthwhile looking into whether or what the exact rate limiting requirements would be, and if that is alone. And because if you say rotating keys is not an option for you, and it's a good point, if you rotate it too frequently, you do have a privacy problem. So then we would have a better understanding if we really need another curve or not. Any other questions? Good.
Are you looking for adoption?
Yes, so I would like to propose that on list.
Okay.
And that would be the next step, yeah.
Sounds good. Yeah, some discussion on the list, and we can do a call, see if there's interest.
All right, thank you.
All right. Next up is Ben with key consistency.
Hello. I think you need to pull those slides. Thank you. Hi. So just to be clear, there is not a draft associated with this presentation. And I am not presenting as in my chair role. But I am going to talk about the charter. So the Privacy Pass charter says that we are going to describe mechanisms that prevent issuers from presenting any key material that could be used to de-anonymize clients. And there's a little bit of ambiguity there, but it sounds like that means that we're going to do something about the key consistency problem. And so we've adopted a draft that talks in a lot of detail about the key consistency problem. And at the risk of speaking for the authors of that draft, I would say that what it really does is that it gives us the landscape of the different kinds of key consistency protocol architectures that we might imagine. And it lists a bunch of these different potential architectures. Really, in my view, there's kind of an infinite number of these things. There's always more options if you're designing some kind of system, but it notes the most notable categories of these different kinds of architectures. It does not talk to us about implementation details or protocols. It's just a concept map of the space, basically. Notably, all of these architectures, and I think any architecture for this problem, necessarily depends on some additional parties that are assumed to be non-malicious. I guess I should say that the client assumes to be non-malicious. But there are a lot of different variations within that. Who are those parties? How many parties are there? What exactly assumptions are you making? Which way does information flow among these parties? Is there a push mechanism or pull mechanism, and all the different legs and where information flows? I should say that in general, there's sort of a trade-off where some of these systems involve just one extra party who is relatively strongly trusted, and some of them add many secondary parties who are then individually much less trusted. So that's one piece of background. The other piece of background that I want to talk about is the private state tokens work. I should say I'm not involved with the private state tokens work, and there are some people here who are. So I'm probably going to get some of the history here wrong, and I'd welcome being corrected. But this, for those who haven't been following, this is the W3C incubator proposal that would expose Privacy Pass to the web. In my view, this is the real customer for Privacy Pass. This is the key reason to do Privacy Pass is in pursuit of these web use cases, and that would flow through something like private state tokens. So there are a number of private state tokens documents right now. It's in a very early stage, I think, at the W3C. But it talks about what assumptions it is making from us as the Privacy Pass working group, or the people who are defining the Privacy Pass protocol. And it says that this protocol should ensure that issuers publish a public key commitment list, and the sentence is a little hard to parse, but I think it says the protocol should verify that the key commitment list is small, and the protocol should verify consistency of this key commitment list. But we really have not provided any kind of consistency verification. So I'm wondering if we're actually sort of living up to the requirements that are being set for us. I like the word should here. I kind of feel like somebody has given us an RFC style should and told us as the working group, like, this is what you should do if you're the Privacy Pass working group. So what happens if we just kind of ignore this problem? But I think the private state tokens actually tells us what they intend to do if we don't solve the problem. And it says that the draft specification for in the W3C format says each user agent fetches the key commitments from issuers at a regular cadence and concatenates them into one big map blob and then broadcasts this blob to all clients. So this is a totally solid consistency solution in my view. Like it achieves the consistency goals. But I can't say I'm a big fan of it. It has a couple of, I think, important issues. One of them is that only issuers pre-selected by the user agent can be used because each client is just checking its copy of the global broadcast database, and it's the user agent who's deciding who gets to be in that database. So this limits the number of issuers in two different ways, right? The user agent has to go through and approve all of these issuers so that they might not go find all of the long tail of potential issuers. And also, even if they were willing to do that, that would create potentially a very large map of all of the issuers in the world, which then has to be broadcast to all of the clients in the world every time the keys rotate. So it's kind of, for technical reasons, limited to a smallish number of issuers. And conversely, if you're trying to operate the user agent, this creates a high barrier to participating in the Privacy Pass ecosystem. You have to take on this role of operating this key distribution service, which must be quite reliable, or the Privacy Pass system for your users will fail. And you have a curation job to figure out which issuers to put on the list and which are, not notable enough. I think that this probably would limit the number of especially sort of open, less professionally maintained user agents that are able to participate in Privacy Pass. So in my view, this is strongly consolidating, and that might be a good reason to see if we can do better. And I do think there's a hint about what the right solution looks like. This is sort of repeating myself for people who've seen the double check work, but this is again a quote from the private state tokens work, which says a version of something that many of our documents say, which is that if the issuer can use network level fingerprinting, then it can probably break the privacy guarantees of Privacy Pass. In other words, we pretty much have to assume that Privacy Pass is used through a proxy in order to conceal the client's IP address from issuers. And that proxy is trusted in a particular way. It's trusted in a way that looks very much like the oblivious HTTP relay threat model, where we don't trust that proxy, to terminate TLS and see all the plain text of all the user's connections, but we do trust it not to collude the issuer in order to preserve the client's anonymity. You can think of this, when we say we trust it, another way to say that is we weaken our threat model. So we essentially exclude certain attacks from our threat model because we don't know how to defend them. And so we just hope that some higher layer of society solves that problem for us. So if you agree with that sort of assessment, then here are some goals that a consistency protocol might need to fulfill for us to think it was a good solution. One important thing is that it allows user agents to solve this problem without having to design their own protocols and then operate their own services using those protocols. That, I think, is the requirement that causes us to need a concrete protocol. Otherwise, we can just, like our existing key consistency draft, provide essentially design guidance to the user agents and say, here's the kind of system that you should design. It would be nice if clients can use any issuer without needing their user agent to have approved that issuer in advance. It would be nice if issuers can serve any user agent without the issuer having to know about the user agent in advance. Those go to these consolidation questions. And it would be nice to avoid adding even more trust assumptions. In other words, weakening our threat model even further than we already have. So that's some goals that we might have, but I think there are probably other goals that other people in this group might have too. Tommy, Polly?
If you have more, we can go on. How much more do you have?
So this is my last slide.
Okay.
I think that there are different things we can do here. We can ignore this problem, and the user agents will do something. We can say we're going to solve this later. Like we're going to say we're going to treat this as a separate working group, and we're going to start a long process. Or we could say, this is in scope for us in Privacy Pass, and we're going to solve it now. And if so, we have different ways forward there. I wrote a draft that I think happens to meet these design goals that I've listed here. That draft also, inside the draft, mentioned some sort of technical problems that specific approach creates. And so I don't know if that's the best solution exactly. We could create a design team to try to puzzle out what the right approach is. We could say, everybody submit your favorite solution to the working group and we'll argue about which one is best. Maybe there's another way too. But this is my last slide. And over to the queue.
All right, thank you, Ben. Tommy, Polly, Apple. So I totally agree with all of the goals you have. And do you mind going back to that slide so we can talk about them? Yeah, so yeah, I think these are all 100% right, and I can't think of other things I want to add to the list particularly. I do think this is definitely in scope, and I think we already have one solution in the architecture that works well, and we can certainly have more. We can talk about more, but at least one of the deployment models, I think, meets all of these. So I think, I'm not sure when that private state tokens text was from, but it clearly doesn't, it's not talking about things with the split issuer attester role that explicitly calls out the proxy. And I think when you do have that, which is exactly what we've been implementing and deploying, then it is kind of the natural way to use the proxy and have that double checking and also meet these other goals. So attester acts as the proxy, and this isn't about the user agent maintaining a list anymore. It's about the attester you're going through. And the nice thing here is not some list that needs to be propagated to clients. It's whatever thing that they're already using for attestation already has to know the different issuers that it's able to work with and has the key configurations for them. The key configurations don't need to be redistributed to the clients necessarily, although they could be. Either essentially you trust the issuer, the attester to check for you, or you have it kind of give you a copy of what it has as a lookup. I mean, we could spell that in different ways depending on what the trust model is with the client and the attester, but we don't need to distribute the large list of all of them. We just know that in the time that I'm actually getting a particular token from a particular issuer through this attester, I can do that check for that one. I don't need to know the whole field of them. This allows you to have an extremely large and dynamic set of issuers. So I think it solves the allow clients to use any and all issuers. The clients need to have zero relationship with the issuer other than I got a challenge for this issuer and I tried it through my attester and the attester said, yep, I know about this one. I checked their key config and you're not being targeted. And then I think another consequence of the attester being different from saying the user agent, and every user agent in the world needs to build this infrastructure, is that different user agents can share an attester. If your attester is based on a CAPTCHA or based on your Gmail account login or something, many different user agents can share one. And in that model, it shouldn't be hard for user agents to join. It's just you already have the problem of who is going to do your attestation. And once you have solved that problem, you've solved the problem of who is going to help you with key consistency. And so we can collapse these. And I think this helps us get the last goal, which is avoiding extra trust assumptions.
we already have to have one trust assumption about how we do our attestation and who we trust to do that. And let's just leverage that relationship to solve our key consistency problem at the same time.
Eric Orth. I think this is a statement I've made multiple times before. I'm going to keep making it, but I think this is a difficult problem to solve. And I think Ben has a pretty good list of goals here, and especially the stuff about avoiding adding any trust assumptions or adding more parties you trust. It's a hard thing. I think maybe not necessarily for all usages of these technologies, but we're going to have some that will want to achieve all those things. And if we don't give any specific spec on laying out one clear way to do it, different people are going to get it wrong. And so I think it'd be very, very helpful and is very much needed to have at least one spec saying, here is a specific protocol you can use to ensure key consistency getting all these things. And yeah, well, it has maybe some problems that can be debated about. I think the draft that Ben had in one of his other slides is one option that should be considered, and certainly others should be considered too. But I think it's a problem that needs to be solved, and we need at least one spec out there saying, here's a golden path, here's one clear way to do it. Maybe not everything will use it, but we need at least one out there.
Chris, but yeah, Tommy, I think I would agree with everything you said. Like most of the major deployments that I'm aware of do have the benefit of just leaning pretty heavily on the attester to help with consistency in this particular case. But for some of the deployment models, that might not be true. Like when things collapse, depending on what type of attestation you may be doing. So there is perhaps a gap between like what's possible today in current deployments and what would be possible if you did deploy it in a particular case. And navigating that gap via any of the proposed, ways forward you have here, like start with double check and try to make that be the standard protocol, spin a design team to, explore the gap and, spit out something for the working group to consider. These all seem fine. But I like, it's hard to say, or it's hard for me to see that this is just generally speaking, not a solved problem. It just hasn't been solved for all possible use cases right now. So, that is not to say that I'm not disinterested in looking at this the particular places where it hasn't been solved. Just to say that we just want to emphasize that we do have a solution right now that works in practice that does not require like a specification or anything to get it right.
Stephen Velez, I think I mostly agree with Chris's points about like different use cases are going to require like slightly different models here. I think the private access token attester issuer split, I think works well for that use case. I think it might not work as well for like arbitrary issuers on the web that like each issuer wants to do different things, because I guess in the PST model, like the attester is like attesting to different facts. Well, I guess in the private access token model, like each issuer is effectively still attesting to whatever fact the attester they work with is doing. I guess also some of the problems of like who can be an issuer gets pushed off in the attester issuer split. I mean, unless the attester just like allows anyone to be an issuer, which seems to, I thought there has to be some amount of trust from the attester to the issuer. Yeah. So I guess, okay, in that case, like for larger issuers, I guess that's fine. And I think works better where like all these issuers are doing this like one attestation promise, while other models want like lots of different reasons and attestations.
Yeah, I think it's definitely fair to say that I approach this from basically the private state tokens architecture question, and the private access tokens approach is a little different and maybe doesn't suffer as much from this problem. I think, yeah, I'd be very interested in trying to figure out, what the path forward looks like at the W3C for those two things, and making sure that we're providing the consistency solutions that the W3C is going to need.
Matt Finkel, Apple. Yeah, so I definitely agree with what you've said, and that this is an important problem, and particularly if this working group needs to come up with something that it agrees with that is a solution, then we should not just defer to individual implementations and deployments.
In terms of the existing consistency draft, like it's only informational. Like the whole point is just to come up with an understanding about what the options are. And I think either building off of your draft or building out a design team to hash out other details and whether we should build something or, you know, design something else that does have more general use. I'm happy with both, and I'm happy to help with the design team if that's the way we decide to go.
Great.
I guess one quick comment. So a lot of the text here was taken from the private state tokens work, which has been a source of great confusion when talking about these things in practice. Private state tokens is not based on Privacy Pass right now. It is not interoperable with the standard that we're working on here. And I think it's really important that when we're talking about consistency in this group, that we focus on consistency as it pertains to Privacy Pass, the protocol that the IETF is working on. And once private state tokens converges on it, then like, you know, we get the benefit of like one solution, you know, potentially fixing many problems. But I don't want us to, you know, explore this key consistency problem on the basis of private state tokens, which is this W3C thing, which is completely separate from, you know, what private state tokens or what Privacy Pass, which is just basically what private access tokens is under the hood. So I really hope we can just focus on Privacy Pass, the protocol, not private state tokens or private access tokens or anything, and constrain ourselves to consistency in that particular problem space. Thanks.
I guess like ignoring the intricacies of privacy, private access tokens, private state tokens, still in the Privacy Pass document in like architecture, we do have like, we have the split mode, there's like a tester issuer, but like we also have the ability of those two things being the same party. So maybe we need to say like, that's just not allowed, or we're only focusing in the case that they are explicitly two separate parties. And that like maybe pushes off this consistency question. But if we don't do that, like it is still a problem in the world that those two parties end up being the same, right?
So to agree with both Chris and Stephen, try to synthesize what they were saying. So yes, we're talking about Privacy Pass. Private state tokens needs to be updated to align with Privacy Pass. So there's plenty of opportunity for it to rejigger things. Private access tokens is at this point, a marketing name that we use for a WWDC talk. It's just Privacy Pass. It's not a different thing. What we should focus on, as Stephen was saying, is that there are different deployment models in the architecture where you have a split attester and issuer, and you have a joint attester and issuer. And I think what we could do as like the step here, yeah, let's do a design team or something, but like let's have either we have one document that is key consistency approaches for Privacy Pass, and it has two sections of if you have a split attester issuer model, here's the recommended way of doing key consistency, and it's essentially what I just described. And if you're doing joint, here's the way of doing it. And we need to talk about that, and I think that's the harder problem for the design team. And if we think that's too hard to tackle altogether, let's write two documents, and one is key consistency for split attester models and key consistency for joint attester models. And that I think fits in more generically, and you don't have to worry about, like, yes, it will serve the W3C well, whatever the W3C does, whether or not it has joint or split attestation, but it also will serve other use cases if they need it.
Thanks. This discussion has definitely been very helpful for me for understanding the landscape here. I would be really interested to know, you know, which of those, the split or joint model, we think the W3C is likely to end up relying on. I want to add one more interesting sort of question to this topic, and that is that this consistency problem applies to Privacy Pass, but we're not the only place where there is a consistency challenge of this kind. There's also clearly a closely related consistency problem in Oblivious HTTP, and potentially interesting, relatively similar consistency problems even sort of outside of this in topics like binary transparency. You know, can I prove that I'm seeing the same version of this website as everybody else? So as we, you know, if we are designing a protocol, I think it's interesting to think about how many of those use cases we can satisfy.
Well, one final, I guess, comment. I wonder if the current sort of expectation of the W3C from the IETF for this group is still accurate or still representative of like what this group is delivering. Like when we were chartered, like looked at the charter text, it talks a lot about this HTTP based API that potentially W3C people could use for consuming things. But since its initial charter, we've sort of like changed how we interact and like do privacy pass HTTP layer. It's no longer like an API. It's like just this challenge. It's just like HTTP authentication. And with that mechanism, it's not clear that there's really much that needs to be done at the W3C layer. So I'm not a W3C person. I'm not like participating in the group in which that's being developed, but I wonder if like we need to perhaps like reset expectations about what this group is providing to the layer above. Like maybe that means, you know, they will change course or align with us or whatever, but it seems like things are perhaps no longer aligned as they once were.
Thanks. So I'll say that my preferred outcome here, I think, is probably a design team. I would welcome, first of all, volunteers. If you'd like to participate in a design team, and we will see if there's interest in that. If there's enough interest to pursue that, and then we'll figure out how to get it started. I should say I have not cleared that comment with my co-chair, so don't take it as the statement of the chairs.
No, I think a design team is a good idea.
Are you looking to make this concrete now, or I'm not sure what the process is for that.
I mean, I think if you're interested, let the chairs know, and we'll confer. And we don't need to do that now. Yeah. All right. Moving on to the next, we have public metadata tokens. Hi, Scott. Let me get rid of this presentation.
Actually, it might be better. My internet is in and out here.
Okay.
Is that
mine appears to be as well? Can you share, Ben? For some reason, I'm not connected.
Yay! Thank you. I'll just let you know when we go to the next one. Hi, everybody. I'm Scott, Google. I've been working on this concept of using public metadata within privacy pass tokens. This particular presentation is not presenting a draft to be adopted yet, although there is one that we've written. We just wanted to introduce the concept and encourage participation in conversation around the utility of public metadata in the privacy pass space. So this work that we're talking about really relies heavily on the work that Gauss presented in the CFRG earlier today, where he introduced a concept that builds upon blind RSA to introduce a partially blind RSA that allows propagation of metadata that can be signed and verified and viewed by all three parties there. So this work obviously has a lot of help from Gauss, Chris, Kevin, as well as Stephen and Tommy. All right, next slide, please. So just to introduce the concept of metadata and where it's propagated within Privacy Pass, this looks like a pretty classic Privacy Pass flow where the client will make a request, get back a challenge, they'll do some attestation, and then we can introduce our first metadata bit here, which is they'll, in their token creation, also bind their tokens to some metadata that they come up with. This can be an opaque blob. The metadata is sent off to the issuer. The issuer, if they're happy with the metadata and they want to sign this particular request, they'll sign. The metadata is now bound to the signature. It cannot be changed in the scope of the signature anyway. Response is sent back to the client. And then the client can present their, replay the request with this token and metadata attached. And then if the origin is happy with all that, they can continue. We'll now talk about the motivation a bit. Next slide, please. So really, what's the purpose of placing this metadata in? Why is it useful? The existing publicly verifiable token is 0x02 based on blind RSA. You can imagine building a protocol that encodes some small amount of metadata using this token. For example, you may deploy multiple keys at once and say, this key is for this particular bit of metadata and this other key is for this other bit. You can also imagine saying, hey, I'm going to have these expiry groups that are available. So maybe I'll deploy 1 key, 2 key, 3 key. And clients maybe in a cache redemption context can try to validate it against these different keys to indicate that they're in a particular metadata group. This can get tricky as your metadata size increases, and this is something that we found in analysis trying to deploy something like this, especially for expiry in the face of. So imagine, let's say we deployed metadata that needed to be per country. Okay, you now have about 300 different metadata groups. Now you want to have pretty small expiry slices, and so you start saying, hey, maybe I'll have like a 1 hour expiry in a cache redemption context. Okay, I now need to rotate my keys every 1 hour, maybe with some overlap to allow for public key propagation. And what you end up creating is kind of this like reliability ticking time bomb, where if your key rotation stops and you haven't implemented things correctly such that you'll continue to validate against these keys that are now expired, it can be very difficult to keep the system up. And that becomes a concern. There's also concerns around if your private key material, for example, is stored in an HSM. It can be difficult to convince these HSMs, depending on your particular implementation, to even sort of continue to validate. So these are a couple examples of why you'd want metadata, and also why it may be hard to build on the existing protocols to use it, and why we started using a different cryptographic protocol. Martin?
Yeah, I just want to ask a question about this differentiation requirement that seems to have appeared here, because that sounds like a bad requirement to me and directly at odds with the goals of the group. We don't want to be able to give the servers the ability to put users into groups. As soon as they can do that, that creates the ability to, I guess, track people and other unpleasant things. Can you expand on that just a little bit more?
Yeah. So I think this concept already exists in the existing architecture. You can imagine creating multiple issuers that differentiate clients for different applications. So say for the country example I gave, actually I'm going to use a different example. Say I want to, my application needs to differentiate an app version. It's not necessarily a privacy issue to say that I need to differentiate the app version at signing time. It is a privacy issue if you don't have enough clients in each group. And so we could deploy an issuer for each app version, and we need some way to determine that there are many, many clients that are being used on each issuer. But instead, go ahead.
I was going to say, I think there's a distinction between the differentiation that occurs on the origin side and the differentiation that occurs on the issuer side. And if the issuer is given the ability to make this differentiation through the choice of, for instance, different keys or what have you, that's a real problem, because over time, the amount of information that you release about individuals increases. Whereas if the differentiation happens on the origin side, then, and it's only based on information the origin has, there's no information channel that's then being created between the issuer and the origin. So which side is it?
So the metadata here that we're talking about would be visible to both the issuer and origin and is effectively the same. So unless there's an
Where
extra
does the
side channel
information
that
come
the
from?
issuer in
Because it,
the metadata.
okay. So Chris off mic said the client provides this information. And who causes the client to provide this information? Because we're not just doing this without information. Someone is going to prompt the client to provide this information. On what basis would the client make that decision to provide the information? This is the difficult part that I'm trying to grapple with.
Yeah.
I think if it's very easy to imagine a world in which the origin says, I would like to talk to this particular issuer, and the choice of issuer carries some amount of information about the context in which the tokens are going to be consumed. For instance, it's in this geography as opposed to another one, and that's information that the issuer already has. It's not gaining any more information. Whereas if this were the case that the client is then being sort of prompted to take some sort of extra information and put it in from some other context, then it would be problematic.
Can I give an example of like one type of metadata that I think Scott mentioned or alluded to earlier? Expiry information of tokens was one of the things that I seem to recall you mentioning earlier. So you could imagine, for example, under the perhaps not reasonable assumption that clients have like tightly synchronized clocks, that they say, whenever I go to issue or run the issuance protocol, I'm just going to encode, the expiry timestamp to be like the end of today. And assuming like all clients in the world have the same clock, then like that just means that the metadata is not unique to that particular client. It's just it will be the same across all clients who might run the issuance protocol in that given period of time. But for other types of metadata that don't have like such an easy way for a client to know that it's not unique to them, then it's potentially problematic, which is I think what you're getting at. Like, I didn't quite hear you. I said perhaps. Sorry, I was saying that perhaps it's not the most reasonable assumption that all the clients have like a synchronized clock. So
I think there's a solution. I think it's okay. So if we are talking concretely about expiration time, I think there's a reasonable solution here. The issuer knows what time it is and can set an expiration during a challenge or something along those lines, in which case it would be reasonable for the client to reflect that to the issuer and get something that's come back in that way. The problem that I have is where there's information coming from elsewhere other than the issuer, than the origin, right? That the origin then learns. Yeah.
Yeah, strongly agreed. The issuer provided expiration timestamp might work as well, but then like what happens if the issuer is like, playing funny games with that under the assumption that the client has like an out of sync clock and then uses that to potentially try to convey information to the origin. So there's a lot of like interesting edge cases to consider here, but perhaps there are ways for some types of metadata to constrain the information that flows ultimately from I guess the client to the origin in a way that is not particularly revealing to them. So there be dragons, I guess, is the the takeaway here.
I like to refer to this type of problem as metadata measurement, where you need to understand the size of the group that you're in. And now the size of the group you're in is not just how many users are on this issuer, it's how many users are on this issuer for this particular metadata set. And I think any deployment that's going to use really any version of metadata probably needs to solve this problem itself. How am I going to show to the world and show to all the other clients that they are still private when they're using this particular metadata set? And this is mentioned in the draft that I wrote, and I think we should expand on this. Obviously, I didn't give everybody a chance to read the draft, so that's unfair in the terms of this discussion. But I think this particular problem is very important when you look at metadata. And actually, you can also think of it as an expansion of the key consistency problem, if you will. How often do you rotate keys? Well, that allows you to size, the set of clients that were used on each key. So this becomes, I like to think of them as very similar problems. It's about trying to determine the size of the group that you're Ben, you have your hand raised. Or you're unmuted anyway. Oh, I see. Okay. Cool. So this implementation is based on the CFRG spec that was presented in CFRG that Gauss presented. We essentially propose a new data type. If you're interested, please do take a look at the draft. It's on the data tracker now, and the GitHub is available as well. I've emailed the CFRG about this work, and I will email PrivacyPass as well, so you have a convenient link for it. And I would encourage, let's continue to discuss public metadata because it is not a trivial topic by any means, especially the use of it in this context. And we need to make sure that we're getting this right. Chris?
Yeah, I just want to say I definitely agree that there are relations to the consistency problem that was just discussed, and if we do go forward with the design team, I would like us to also consider not just like key consistency, but more generally like sort of configuration consistency, or however you want to phrase it, which includes the key material, whatever other metadata you might happen to use the protocol, and I don't know, that might have applications beyond Privacy Pass, like OHTTP or whatever, but. Yeah, good idea, Scott.
Great.
Okay,
Thank
any
you for your time,
other?
everybody.
Yeah. I think there's David's.
David Skenazy, Google, cryptography enthusiast. I was told that introducing myself in CFRG as a crypto enthusiast was a bad idea, so sorry about doing that earlier. I just wanted to say that we're working on deploying some mask proxies over at Google to support some privacy features in Chrome, and we're considering using this. So I would love for this to be adopted and get a lot of review from the working group. That way we don't shoot ourselves in the foot. So thanks.
Yeah, Chris +1. I do think that we should consider adopting this draft. It's kind of unfortunate that the current issuance protocols don't support metadata. In fact, when the registries that we've identified have this column for does this protocol support public metadata or not. So at the very least, exercising, and exploring that space of protocols is a good use of the working group's time. So I would support an adoption call.
Okay, thanks. I think we'll try to have some more discussion on the list, but I think this is also a good topic for us. All right, any other business that people want to talk about? If not, then it's the last meeting on the last day. See you next time in San Francisco. All right. Whew.
Like all the work that we did there, it seems like not enough. Yeah.